Okay, this video is meant for my geometry students. We have a test the day after Easter break, or second spring break, and it covers chapter 10. This is going to cover sections 10.6 through 10.7. Might be a good idea. It's been a little while to cover 10.1 through 10.5 in my previous video. Okay, so let's take a look at this problem. This problem is actually from 10.4. Okay, so if you want to make a note, this is a 10.4 problem. All right, so and what it says is the following: the scale factor of the dimensions of two similar wood floors is 4:3. It costs $2.16 to refinish the smaller wood floor. At that rate, how much would it cost to refinish the larger wood floor? Okay, so first we're given a scale factor of 4:3, and this is important. Okay, the scale factor. Now, when you refinish a floor, here's your floor. When you refinish the floor, you're covering the entire floor. So what this is an area problem. So if the scale factor is 4:3, then to find the ratio of the areas, we take the squares of those numbers. 4 squared to 3 squared, and that's 16:9. This is the ratio of the areas, and in a proportion, we will set this equal to the ratio of the costs. So in a proportion, we will set 16/9, which is the ratio of the areas, to the cost of finishing those areas. Now, it says it costs $2.16 to refinish the smaller wood floor. Well, the smaller one would go across from the 9, so that they correspond, so that I'm looking for the cost of the larger one. So now we cross multiply, and we will get 9x equals, and I will do 16 times 216, and I will get 3,456. And I'll divide both sides by 9 to get the cost of refinishing the larger floor. And I got $384, or 384, and that is in dollars. So the answer to this problem is 384. So understand, if you're dealing with area, you have to work with the scale factor squared. Okay, number 2 again is another review problem. This is from section 10.5. Okay, find the area of the regular polygon. This is a 20-gon with a radius of 2 millimeters. Over here, I'm going to put the area for a regular parallelogram. 1/2 A times N times S, right? The apothem, the number of sides, and the side length. Well, I have the number of sides, it's 20. Now, I don't have the apothem, I don't have the side length. Now, this 20-gon, let me draw a picture of one of the triangles. Now, this 20-gon, we've broken into 20 triangles, looking something like this. The radius are the dotted lines. These are radii, so we have 2 millimeters here and 2 millimeters there. This right here is the apothem drawn straight down, and this is the side length here. Well, if I'm trying to find the apothem, I have to work with an angle measure. So my job is to find these angle measures. First, the central angle. To find the central angle, 360 divided by the number of triangles and the number of sides, that's 20. 360 divided by 20 comes out to be 18. But then I only want half of it because I want to work with this right triangle. So over here, I take half of 18. 18 divided by 2 is 9 degrees. We're going to be working with a 9-degree angle. So I'm going to draw this triangle down here, make it a little bit bigger. Here's my apothem. This is my 2 millimeter radius. And now this is half of S. So I'm going to call it X. And remember, we'll find X and then double it to find S. And then this angle right here is 9 degrees. And now, with a 9-degree angle, I'm going to use trig to find these lengths A and X. Now, from this 9-degree angle, this is the hypotenuse, X is the opposite side, and A is the adjacent side. So, to find A first, we're going to use adjacent and hypotenuse. We're going to ignore the opposite. Adjacent hypotenuse is cosine. Cosine of 9 degrees equals the adjacent A over the hypotenuse 2. And I will multiply both sides by 2. So my A comes out to be 2 cosine of 9. And 2 cosine of 9 is roughly 1.975. And that's in millimeters. Okay, so now to find X, that's the opposite side. Again, use the hypotenuse. That's sine. Sine of 9 degrees equals the opposite X over the hypotenuse 2. And multiply both sides by 2. So X is just 2 sine of 9. And that comes out to be 0.313. But that is the That's x. X is half of s. So to find s, the side length, we have to double that. So double x. So press times 2, 0.626. And that's in millimeters. And there we go. So I have my apothem, I have my side length, and I have my number of sides. Plug it in. So back to green. A equals 1/2. Apothem, 1.975 times the number of sides, 20, times S, 0.626. And when I plug this in, I get 12.4. And that would be millimeters squared. So this is a review of finding a regular polygon's area given the radius. Alright, question 3. Moving on to some arcs and circles. Find each indicated measure for circle O. And of course, what I like to do first is just work on the circle. So EH is a diameter. Therefore, we have semicircles, 180 degrees. So EJ is going to be 180 minus 70. 180 minus 70. That's 110. So EJ is 110 degrees. FJ is another diameter. So that means FE is going to be 180 minus 110. And that is, of course, 70 degrees. So EF is 70. EH is a diameter, like we said before. So this is a semicircle. So FH is going to be 180 minus 70, which is 110. But then these two arcs, these two minor arcs, are congruent. So to find each of those, we divide it by 2. And that's 55. So each of these is 55 degrees. And now I have the measure of all of my arcs. So now this problem should be very simple. Let's see. EJH. EJH ends with E and H. That's a semicircle. 180 degrees. FH. FH we found over here. You could also, you could add 55 and 55, but FH is 110. JEG. So JEG. So I'm going to do it right here. So from J to E is 110. E to F is, or you could do a semicircle plus a little bit, whatever. EF is 70, and then FG is 55. So again, it's a semicircle plus 55. That's 235 degrees. And then HFJ. For HFJ, because it's only missing JH, I'm actually going to do 360 minus that 70 degrees, and that comes out to be 290. And there you go. So we have a semicircle, a minor arc, and 2 major arcs. Remember, fill in your picture. That's the best way to do them. Okay, problem 4 here. We're going to find the arc length of the arc in red. And if you can't see, the arc in red is the big arc right here. Oh, it's bad. I'll make it a little bit. This is the arc in red right here. Okay? So, to find arc length, you need to know the angle or the arc measure for your arc. Well, if this is 90 degrees, that's the part we don't need. Then this major arc is going to have an arc length of arc measure of 360 minus 90. That is 270. So this measure right here is 270. So of course, to find arc length, we take the length equals the angle or the measure of the arc over 360 times the circumference. And the circumference, in this case, 18 is the radius, 2 pi times the radius, which is 18. And we will plug this all in. I'm not going to leave it in terms of pi. I'm going to plug it all into my calculator and see what I get. When I plug this in, I get an answer of 84.8. And length is not squared, it's part of the circumference, so it's just units, which are meters. Arc length, very good. Here we go. It says in circle O, the length of arc AB is 6 pi centimeters, and the measure of arc AB is 120, and that's in degrees. What is the diameter? Well, we're going to use this formula. Length equals the measure of the arc over 360 times the circumference. And if they want the diameter, let's use this circumference formula, pi times diameter. So what do they give us? Well, the length of the arc is 6 pi. They give us that. The measure of the arc is 120. They give us that as well. and your job is to find d, and of course d is the only variable. You can find it. Now, first, pi is on both sides. Cross it off. Simplify this 120 over 36. Ooh, sorry. Let me get back to the problem. 120 divided by 36. It's a decimal, but I'm going to leave it as a fraction. So simplified fraction, the zeros cancel. Divide each by 12. You get 1/3. So 6 equals 1/3 times the diameter. And then to get rid of the 1/3, we multiply both sides by 3. That's going to get the d all alone, and 3 times 6 is 18, and that is in centimeters. And there's the diameter in this problem. So don't be afraid that you might have to work backwards in some of these problems. Okay, we're going to find the area of the shaded segment right up here, round to the nearest tenth. So first thing you do is you find the area of the sector, right? We start with the sector. The sector is the pi piece. Area equals, so what is the angle? Well, if this is 60 down here, so is this up here. Right, that's 60, and that makes the arc length, or arc measure 60, and of course that's the angle we use. 60 out of 360 times the area, and the area formula for a circle is pi r, and that's 6 squared. So I type this in my calculator, 60 divided by 360 times pi times 6 squared. And I get 18.8. And that's meters squared. So now we find the area of the triangle. So for the triangle, we're going to use that formula. Area equals 1/2. Now it's BC. It's these two sides. Well, they're both radii. So it's 6 times 6, or 6 squared, times the sine of the angle in between. And the angle in between is that central angle, or the arc measure, 60 degrees. And I'll type this in my calculator, and I will get I got 15.6. Gee, sorry again. So the area of this triangle is 15.6 meters squared. So then to find the area of the sector, or I'm sorry, not the sector, the segment, the shaded segment, we're just going to subtract 18.8 minus 15.6. And that area comes out to be 3.2 meters squared. Sector, triangle, subtract to find the area of segments. Good. Okay, 2 more problems here. Number 7 here, we're going to find the area of the shaded, I don't know if it's a segment, or just a shaded region, the shaded region here, okay? And shaded region around to the nearest 10. So what is this picture? Well, I believe this is a square, okay? So the outside figure is a square, and then we have 2 semicircles inside of this square. So the shaded region is the subtraction of the square minus the 2 semicircles. Well, let's start with the area of the square. The area of the square can be found by taking s squared, the side length squared, and the side length here is 8 squared, and 8 squared is of course 64 feet squared. That's the area of the square. Now the semicircles. Now the 2 semicircles put together make a circle, so really all you have to do is find the area of a circle. Well, the area of a circle is pi r squared. Now those are diameters, so the radius is half of that. 8 divided by 2, which is 4 feet. So in this formula, I will use 4 as my radius, 4 squared. And that is pi times 4 squared. And that comes out to be roughly 50.3. And that again is feet squared. So now to find the area of the shaded, it's just the subtraction of 64 minus 50.3. And when I do 64 minus 50.3, I get 13.7, and that is feet squared. And there is the answer to this shaded region problem. So identify what the bigger figure is, take away the smaller figures, get the shaded region. Last problem coming. Okay, here's number 8. It says in a circle, a 90-degree sector has area 36 pi, inches squared. What is the radius? So this is again another work backwards problem, okay? So remember, area of a sector is the measure of the arc over 360 times the area formula, pi r squared. So in this case, they give you the area. The area is 36 pi. The measure of the arc is the angle measure, 90 over 360, times pi r squared. And of course, they want the radius, so that's our r. Now again, pi on both sides. Cancel it out. Simplify this fraction, so we get 36 equals, the zeros will cancel, and 9 over 36, you can divide both by 9. You get 1/4 r squared. To get rid of the 1/4, times both sides by 4. 4 times 36 is 144. The 1/4 and 4 cancel. That gives you r squared. And to find r, you take the square root. Technically, you get two answers, plus or minus. So the square root of 144 is 12. But we only keep the positive. So the real answer for this is positive 12. And that would be in inches. And there's your radius for this problem. So again, don't be afraid to work backwards. Handle the situation. Okay? Hope this helped. Happy studying, and we'll see you after that Easter break. All right, take care.